In this lesson, we shall learn how to solve equations using graphs. But first, let us do some converting and manipulation. We are given a curve here y equals to x squared plus 2x plus 3. And we are tasked to make one side of the following equations to look like this curve here. You'll notice that this part of the equation is different from the curve, and hence we will remove it by subtracting x on both sides. And we will end up with this. To make this part of the equation the same as this curve, we will need to add back 2x on both sides. And now the left hand side will look like the equation of the curve. Next, you notice that the negative 2 here is different from the equation of the curve, and hence you remove it by adding 2 on both sides. To make this side the same as the curve, we will need to add back 3 on both sides, and we will get this. And once again, the left hand side now looks the same as the equation of the curve. In order to do this, we will always shift whichever part that is not the same as the graph to the other side. And then we will add the terms that are now missing, so that one of the sides will look exactly the same as the equation of the curve. Let's look at 2 more examples here. Which part is not the same as the curve? Yes, this part here is not the same, and hence we will need to shift it to the other side. Next, we will need to add back the terms, which is 2x plus 3 on both sides. Simplifying, we will have x squared plus 2x plus 3 equals to 3x minus 2. Now let's try for one last equation here. Yes, this part here is different from the equation of the curve, and hence we will need to shift it to the other side. Simplifying the right hand side, we will now have this. Now how do we make this the same as the curve here? And yes, we need to add 2x plus 3 on both sides. And then we will have this. Now it is very important to learn how to do this, because later on we will need to use the curve here to help us to solve equations like this. Now let us look at the first example. We have finished plotting this curve here, y equals to 2x squared plus 3x minus 5. And now we are asked to solve a series of equations. For example, we are asked to solve this equation here. The first step is always to convert this equation to look like the equation of the curve. Now since this part of the equation is exactly the same as the curve, there is no manipulation needed. Now let's recall, to solve 2 equations simultaneously, it means that we are finding the intersection points of 2 graphs. For example, when we find the intersection of these 2 graphs, we are actually solving for the values of x and y. Therefore, if we find the intersections between y equals to 2x squared plus 3x minus 5 and y equals to 0, we are actually solving this equation here. So first, let us draw y equals to 0. And hence, what is the intersection between this curve here and y equals to 0? Yes, it will be these 2 points here. Can you identify the values of x? The values of x will be x equals to negative 2.5 or x equals to 1. And therefore, we have used this curve here to help us to solve this equation. Now let us see how do we solve the next equation here using the curve. Again, we will convert this equation here to look like that of the curve. The equation of the curve is given here, and the equation that we need to solve is this. Now you notice that this part here is different from the curve, and therefore we need to, shift to the other side. And now we need to subtract 5 on both sides so that it will look exactly as the equation of the curve for the left hand side. Now what does this mean? This means that we need to find the intersection point between y equals to negative 3 and y equals to 2x squared plus 3x minus 5. Since this part here is already drawn previously, we just need to draw y equals to negative 3. And the intersection points will be these 2 points, which is x equals to negative 2 or x equals to 0.5. Next, we are asked to solve this equation here. Again, remember to convert to look like the equation of the curve. To solve this equation, you notice that this part here is actually different from the equation of the curve, and hence we will shift it to the right hand side. To make this look exactly the same as the equation of the curve, we need to plus 3x and minus 5 on both sides. And hence on the left hand side we have this, and on the right hand side we have x plus 2. This means that we need to find the intersection points between the quadratic curve that we have drawn and y equals to x plus 2. The question is, how do we draw y equals to x plus 2? In order to plot this straight line, we will need a table like this. You can use any values of x that you can find on the x-axis. Well, the easiest one to use is of course 0, 1 and 2. When x is 0, y is 2. When x is 1, y is 3. When x is 2, y is 4. And hence we can draw a straight line like this. Finally, the intersection points between y equals to 2x squared plus 3x minus 5, which is the curve here, and y equals to x plus 2, which is the straight line here, will be x equals to negative 2.4 or x equals to 1.45. We shall now look at another example. Now we have plotted this cubic curve y equals to x cubed minus 6x squared plus 1, and we are now asked to solve this equation here. Similarly, always convert this equation to look like the equation of the curve. You notice that the left hand side here looks exactly the same as the graph already, and therefore in order to solve this equation, we just need to find the intersection between these two, which is y equals to 0 and y equals to x cubed minus 6x squared plus 1. Can you see how many points of intersection there are? Yes, there are 3 points of intersection, namely x equals to negative 0.4, x equals to 0.4, and finally x equals to 6. Next, we are asked to solve this equation here. Yes, you will notice that this part of the equation is different, and hence we will need to shift it to the right hand side. Simplifying, we will have this. To make this part of the equation the same as the curve, we will need to plus 1 on both sides, and hence we will have this equation. To solve this, all we need to do is to find the intersection point between the curve here and y equals to negative 15. By drawing y equals to negative 15, we will find these 3 intersection points, and therefore the values of x will be negative 1.4, 2, and 5 on 5. Let's look at yet another example. We will need to convert the equation to look like the curve again. And we notice that these two parts are different, and hence we need to shift it to the right hand side. Simplifying the right hand side, we will now have this. To make this part of the equation the same as the curve, we will need to plus 1 on both sides, and hence we will have this. And hence to solve this equation, we will need to find the intersection between these two curves here. So how do we draw this straight line here? Yes, again we need to plot a table, and we can now plot the straight line. In this case, there's only one point of intersection, and hence x will only be 5.4. Some important things to note. Always convert the equation that we are asked to solve to look like that of the equation of the graph drawn, so that we can make use of the graph to help us to solve the equation, instead of redrawing another graph. Also remember to plot the tables in order to draw straight line graphs in the form of y equals to mx plus c. And finally, remember to draw your lines longer so that it will intersect with all the points on the graphs.